Hello everyone. This video I'm going to show you another example of integration and sure, integration. Last video show a very simple function x squared doing the integration of x squared, and this time I just show another little variation, a little more complicated function, just a little. It's 4 minus x squared, and and I will also use the original method to do the integration. Very original. Just add the area, add a tiny area, and the terra together, and then I will just use the integration rule of power function to do the integration. Okay, so that's in previous video we have already said that the doing the integration is calculate area under the curve. Suppose I have a 4 minus x squared is a function, and I want to find area between 1 and 3. Yeah, find the area under the curve, and the range is 1 to 3. So we use the original. So we also use the right endpoint. We also use the right endpoint. We also use the right endpoint. So you might think, is that a left endpoints method? Yeah, sure. There's also a left endpoints method. But eventually, no matter you use right endpoint and left endpoint, the answer is all the same. The answer are the same, both are the same. So I just demonstrate right endpoints method. Okay, so the right endpoint method, so suppose I have xi here, and it is corresponding to f of xi, and I took the right endpoint, okay, and the space is also delta x, okay. And last video we have shown that the tiny patch, the area of tiny patch of the rectangle is f of xi times delta x. Okay, delta x is here. Okay, it's just xi here. So we choose the right endpoint. Okay, the right endpoint, the difference, the space between the right endpoint and xi is delta x, and the height is corresponding to f of xi. And we have two summation over them. Okay, and okay, so the next problem is, what is our delta x and what is our xi? So we want to do the integration between 1 to 3. So our delta x, let me suppose I slice. Well, our delta x would be, our space would be, okay, the range, okay, 3 minus 1, and I slice n point, slice n species, not species, n pieces, okay, divided by range by n pieces, okay, divided by slice this range in n pieces. Okay, and our n is approaching to infinity. Okay, so our range is from 1 to 3. Okay, so if with this space, so what's the point? What's xi? Our x sorry, our xi would be 1 plus our delta x is n over 2, and 1 plus n over 3, and 1 plus 6 over n, and our goal is long way to 3. Okay, let me go down this. Okay, so go all along way to 1 to 3. So our endpoint is 3. So how to express this? How to express our xi? Our xi is 1 plus 2i over n. Okay, so if I equal to n, what is its endpoint? Okay, if I equal to n, that means xi, that's an endpoint, the real endpoint of the integration. Okay, so and I start from 1. Okay, I start from 1. Okay, I start from 1. So our first point will be 1 plus 2 over n. And you might think, what's about this original point? Okay, that's we call it's a right endpoint method. We start from the right endpoint. And you can think if n is approaching to infinity, actually the first point is very close to 1. Okay, so that's the remainder. You might think, why it does not start from 1? But actually, when n approaches to infinity, it starts from very close to 1. Okay, that doesn't change the result. Okay, that doesn't affect the result. Okay, so we have this expression. So let's start it. Okay, we can start the calculation. Okay, so when we go, our summation, we will have summation I f of xi is 4 minus xi squared times delta x. Delta x is n over or 2 over n. So xi is 1 plus n 2i over n. So summation I 4 minus 2i over n and square okay, and times 2 over n. And so let's continue. Okay, some algebra work. I just read it quickly. 1 plus 4i plus n square 4i square times 2 over n. And then, yeah, let's continue some algebra work. So, yeah, let's see. So this is just algebra work. I believe you all can understand this. So I don't address this too much. N square 4i square minus 2 over n. So finally we get this. Yes, n over 6 over n minus ai n square minus ai over n square 8i square over n to the power 3. Okay, so we almost finished the calculation. So we can summation term by term. Summation term by term. So its first term is summation 6 to the power 6 to over n and summation I. And the second term is, because we're doing summation over I, so n is nothing to do with summation, so we can factor it out. And summation I is I. And I start from n. And says I start from 1. Yeah, I should address this. I start from 1. I start from 1. I start from 1. So the next one is n a over n3 summation I equal to 1 to 1 to n. Okay, 1 to n. I should make this up. Make this up. Okay, sorry about that. And okay, anything left? Okay, a over n to the power 3 is summation I square. Okay, so and then use some high school mathematics you have learned in summation. So what is this? This is just n, right? This is just n. Summation I equal to 1 to n, and 1 is just the n. So what is this? Okay, in last video we have shown that this is just 1 m times m plus 1 over 2. And what is this? Yeah, in last video we already mentioned that this relate to your high school mathematics. N times m plus 1 times 2m plus 1. Okay, so we lumped this thing together. So what we have, n 6 times n minus a over n squared and 2 and n plus 1 and minus n to the power 3 8 and 6 n times 1 and plus 1, 2 and plus 1. Okay. And so, okay, let's do some algebra work. First term is easy. And second term, okay, is 4. So what would we have? It's m squared plus n. So it's 1 my plus 1 over n. Okay, so what's the next term? Is 4 over 3, and let me do the math here. Let's do the math here. Yeah, 2 and 3 and n squared plus 3 n squared, right? Plus n, n squared, 3 n squared, 2 n squared. Okay. So it divided by n to the power 3, so it will be 2 plus n over 3 over n plus 1 over n squared. Okay, we'll finish the calculation soon, and at the very beginning we had stressed that we have emphasized that n approach to infinity. N is a huge number. So if n is a huge number, what's the answer? If n is a huge number, this is 0. Is 0 is 0. So the answer is 6 minus 4 minus 8 divided by 3. It's so the answer is. Did I do the right calculation? Hmm. Did I do the right calculation? It doesn't look like the answer. Two. Did I do something wrong here? Yeah, let me check. Okay, okay. Let me do check from the using integration rule. Okay. Did I do the right calculation? Okay, let's check. Okay, so we use integration rule. This integration can be divided by 2 terms, dx minus 1 3 x squared dx. So the constant during integrations actually, and last time I showed it actually is x0 to the power of dx minus 1 over 3 x squared dx. So actually this 4 times 3 minus 1, 3 minus, this will be 1 over 3, 3 minus 1, 3. The answer will be is 8. This is 8, and minus this will be 27. So it's 326. So it's 3 minus 2. Oh, okay. Okay. So it's minus 2 over 3. So let's check. Minus 2 over 3. Yeah, it's right. Okay, I did it wrong. I did it right. Okay. Okay. I'm afraid I'm calculating wrong again. Okay. Okay, so that's I use the origin definition of integration and using the power law of power integration rule for power function to do the same thing. The answer should be the same. Okay, even you use the original way, the very fundamental way, and use the integration rule of power function, they should have the same answers. Okay, so here's the video. I hope you can understand the integration more. Okay, so see you in another video. Bye bye.